Good afternoon, guys, and today we're going to learn how to graph tangent and cotangent functions. So we've already learned sine and cosine and cosecant and secant. Those graphs kind of went along with each other. They all had a period of 2 pi and were relatively similar in the way they looked, especially with the cosecant and secant graphs being graphed off sine and cosine graphs. Tangent and cotangent, however, are going to be a little bit different. And the big key thing with these graphs is they have a period of pi instead of a period of 2 pi. So that's something to keep in mind as you're working any problems with tangent and cotangent. Whenever you solve for the period, instead of doing 2 pi over b like we've been doing in the past, you will use pi over b. Alright, so today we're going to look at the parent functions for tangent and cotangent, and then you could use these parent functions to graph phase shifts and vertical shifts and the like, depending on what was given to you. So first we'll start off with tangent. So I've written down some numbers here. We have negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4, and pi. So you could get out your unit circle and go through these to see what the tangent would equal at each one of these. Now remember, on our unit circle, the tangent is going to equal the sine value over our cosine value, which is the same as y over x. So you could go to each one of these spots on your unit circle and pick out those values to find the tangent. So at negative pi over 2, we would have that our tangent is undefined. At negative pi over 2, tangent would be undefined. We'd get 1 over 0 there. At negative pi over 4, which would be like negative 45 degrees, we would have that our tangent was negative 1. At 0, we would have that our tangent is 0. At pi over 4, 45 degrees, we'd see that our tangent is 1. At pi over 2, we would have that our tangent is again undefined. At 3 pi over 4, you would have negative 1. At pi, you would have 0, and this would keep on repeating in either direction, just like sine and cosine. It does not end. It continues along the x-axis forever in either direction. So, looking at these, we can graph these points on our graph that we have here to the right. Now, again, whenever we have an undefined value, we need to use asymptotes. So, at negative pi over 2, I'm going to have a vertical dotted line. And at pi over 2, I'm going to have a vertical dotted line. Okay, notice that the total distance between these 2 points is pi, which is the period of my tangent graph. So whenever you're graphing tangent, you want to move half the period to either side of your y-axis so that you can graph it correctly. Alright, so now we could go in and fill in where our tangent graph will be at 0. So for instance, at 0, we're going to be at 0. So I could put a dot there. At pi, I know my graph is going to be at 0, so I could put a dot there. At negative pi over 4, we're going to be at negative 1. And at positive pi over 4, we'd be at positive 1. At 3 pi over 4, we'd be at negative 1. And our graph would be ending. So what our tangent graph will look like is kind of this curving line. Go off the graph here. It starts at the bottom left-hand side of the graph and moves up through the top right-hand side of the graph. Okay, so a little bit different from sine and cosine. It's not a continuous graph, kind of more like secant and cosecant, where it's going to be broken up by the asymptotes. And so this is what your tangent graph will look like. So we could then go down and look at our cotangent graph so we could find the values there. Now, the cotangent is the reciprocal of tangent, so any of the values for tangent we could have just taken and put in over 1, much like we did with the secant and cosecant from the last video. So for instance, these negative 1s and 1s will all be the same for my cosecant graph. Okay. Anywhere my tangent graph was at 0, my cotangent graph is going to be undefined. So my cotangent graph will be undefined at those spots. And anywhere my tangent graph was undefined, these values would have been 1 over 0 from your unit circle would now be 0 over 1, and so my cotangent graph will be at 0 at those locations. All right, so again, we could go in and graph these. So at 0, I'm going to be undefined, so I'll draw my asymptote on the y-axis. All right, at pi will be undefined, so I'll draw an asymptote there. And again, if you look, it's the distance of pi between those two asymptotes, and that's the period of our cotangent graph. We could go in and fill in our zeros, so negative pi over 2, we're going to be at 0, and at pi over 2, we're going to be at 0. All right? And then all the points will actually be at the same spot that the tangent graph's at. So for instance, tangent was at 1 at pi over 4. Cotangent will also be there. It'll also be at negative 1 at 3 pi over 4, much like tangent. At negative pi over 4, it'll also be at negative 1. But since we've shifted these asymptotes and these zeros, now instead of curving from the bottom left to the top right like my tangent graph, my cotangent graph starts at the top left and curves down to the bottom right. So almost like a flipped image of the tangent graph. So there you have how to graph your tangent and cotangent functions. We can post videos a little bit later on how to do phase shifts and vertical shifts of these functions so that you can see how to move them around and how that's going to be different than with a sine and cosine or a secant and cosecant function. So thank you guys for watching. Hope you enjoyed, and we'll catch you next time.